All right, hey everyone. Thank you for joining us for the webinar today, Managing and Maintaining a DevOps Assembly Line. We have a fair amount to get through. I'm just gonna let everyone know a few things up front. We are recording this, so if you have to drop for it at any time for any reason, or if you have a colleague who is unable to join, they will be able to watch this after. We also are able to take questions. We'll be having some time at the end to answer them. So as soon as you think of questions, please ask them because we love getting them. And otherwise, I think we can just get started. So here's our presenter for today, Viktor. Viktor, here you go.
Thank you, Max. Okay, so I will be talking about assembly lines, not only applied to DevOps, but in general, because I think that there are a few misconceptions that might need clarifying. So let's get started. For those of you listening to me for the first time, my name is Viktor. This is how I look like. I think that even webcam is there, so you can see me live. I hope, I think. Anyways, I work for Cloudbees. I'm a consultant for Cloudbees. I help companies do things better, to put it in a certain way. I'm also one of the Docker captains, so I'm not only involved highly in Jenkins, I'm involved with Kubernetes, with Docker containers, and many other things in between. Read my blog, random nonsense, but still you might read it. There are some courses, there are some YouTube videos. Just Google my name and you will find all those things, including books. And very important, if you want to contact me, you can just send me a tweet message, or you might send a message saying this is awful. That's also okay. So jumping straight into presentation, what is assembly line or a software assembly line? And I think that those two terms are getting mixed quite often. So let's see. If you look at the definition only of an assembly line, you know, those types of lines that you can apply to a Ford factory, the case that is often used, you can say that it is a manufacturing process in which parts are added in sequence until the final assembly is produced. And further on, you can say that its assembly line is about mass production of a product with the same specifications and quality. So in other words, what assembly lines are trying to accomplish is to produce a huge number of something that is always using the same specifications and are adhering to the same quality standards. And a long time ago, when people were thinking how they organize software production, they were basically basing their assumptions on that assembly line. And I think that they are wrong in many aspects and sense, and yet there are quite a few similarities. And one of them is that what we do does not produce many times the same result. It actually never produces the same result. Every single artifact that we produce, every single iteration of an assembly line always produces a different result. So we are really producing a single product, and we are trying to do that with a repeatable process. But that single product is always different. Every commit produces something new, something different. So it's quite different than an assembly line, right? We're not trying to produce, we're not trying to run 1,000 times the same commit, the same build, same tests that are always going to produce the same result. But actually, every single commit is a completely different product. At least from my perspective, it is something different every time. Otherwise, if you make a commit that produces the same result as the previous one, then you might just as well not do anything because there is no real need for us in that case. So let's go back in time when people figured out how they will organize software projects, and they organized it around something called waterfall. And then they created the waterfall assembly or assembly-like process that imitated those factory productions. And to make things worse, waterfall was misunderstood from day one because the originator of the concept had something completely different in mind. But I'm not going to discuss that. I'm going to discuss how waterfall works in practice. And the way how we envisioned that, like, I don't know, 20, 30, 40, 50, nobody knows how long ago, but long ago, is that we have analysts that think a lot, they speak about customers, they try to figure out what should be the result of what we do, what should be the product, And they spend a lot of time defining their thinking and writing some documents and so on and so forth. And once they're done, weeks or months even later, they would send it to developers. And then developers would develop. They bash a lot of code, they write a lot of stuff. And after, again, weeks or months, we send it to testers. The testers validate. They say, we're very happy. This is perfect. This is peachy. We never saw something as good as this. There are no bugs. And they move it to operators. Operators put it to production. And finally, there is a maintenance team that is making sure that whatever we produced after that period of time is up and running in production all the time, and it's successful, and all those things. And that would normally take months or years. And that, when you look at it, that sounds funny on many aspects. And one of them is that actually that never, ever, ever worked. Whomever came up with that idea, and we all adopted it at some point, long time ago, probably quickly realized that such a combination, all this, what you see on the screen, never truly works. It's enough to spend 1 week in software development to understand that. Because what in reality is happening is that there is no straightforward single line assembly line that does all that, because things are failing all the time. Analysts need to go through, talk with developers and go back and forth and say, this is the requirement, and developers say, no, that's really awful, and they send it back, and then it goes in some kind of a loop back and forth between them. And of course, there are also testers involved in all that, and they also discuss requirements, and they send it continuously back to analysts over and over again, because it's normal that you cannot get it right from the first attempt. And the developers develop, and they say to testers, testers say, no, this is awful. There's a lot of bugs. You misinterpreted features, and so on and so forth. And then there comes another cycle of going back and forth between developers and testers. And then finally, testers say, okay, this is reasonable. It's still full of bugs. We have still 200 documented bugs of what you did. But we are tight on schedule. There is always a schedule, and we're gonna let it slide and move it over to operators who are going to deliver it to integration environment, try it out, and then go to production. And operators, of course, say, no, this is awful. This does not work. You did not do it right because you never talked with us, and so on and so forth. And finally, it goes to maintenance people. Finally, operators say, okay, again, there is a deadline. We're going to let it slide. We're going to deploy it to production. We're going to file another 100 bugs for later. It's never going to be fixed, but let us file it because we love Jira and similar tools. And then it goes to maintenance, and maintenance continues discovering things that simply prevent the system from working. They cannot fix it themselves. They go back to developers, and so on and so forth. So the whole idea of having a linear process where things just work, and they just work because we spend weeks or months in planning, does not really work. There is no real assembly line. There is nothing similar to what Ford envisioned for production of cars. And that's normal because, as I said before, we are supposed to produce, Ford is supposed to produce hundreds of thousands of cars that are exactly the same, and we are trying to produce something that is every time different. So from the very beginning, it does not really fit that thing. But let's add tools to that mixture and see how they really fit into that. So again, going back to that ideal assembly line, and we have analysts, developers, testers, operators, maintenance guys, and many others that I completely missed to put in this diagram. There are also systems architects, software architects. There might be CTO somewhere in the middle complaining about nothing working, and so on and so forth. But I'm going to simplify it with those 5 roles. And then analysts, they use a lot of tools. Everybody uses a lot of tools. They might write some board documents. They might work something in MS Project, or maybe they are actually advanced and say write everything in Markdown and store it in Git, which would be perfect. But more likely than not, they're not doing that. And then we have developers that have their own tools, and they have, I don't know, maybe they're using Visual Studio Code or IntelliJ or Eclipse or what's or not. Maybe they're brave and really old-fashioned and say we are using VI. It does not really matter. What matters is that they have a lot of tools of their own. And then come developers. Developers also use tools. Now, depending on testers. Depending on testers, they might actually use no tools. Their only tool might be a mouse clicking and checking whether things work, or they might be writing cucumber tests. they might be writing Selenium tests, or might they actually go to SonarQube and see how bad the situation is through some metrics and statistics and what's or not, right? Doesn't matter really what are the specific tools, but there are many of them, and they usually overlap. Developers would use Cucumber as well, or Selenium, and then testers and operators and what's or not. And then we go to operators and they say, okay, we need to create virtual machines. We might be building Docker images, or maybe we're deploying to Kubernetes. They have their own stuff that is going on, and maintenance guys as well. I could not come up with many examples, but let's say that they store things in Git, or they use tools. Everybody uses some tools. And all those tools are used throughout that assembly line, how we call it, right? And the problem, there are a couple of problems with those tools. First of all, many of them, like IntelliJ maybe, or Cucumber, even Docker, they require us to do some manual work. They requires them to write some code, maybe write some Docker file definitions, maybe some YAML scripts for Kubernetes, and so on and so forth. And on top of that, they help us sometimes to do some automated work and relieve part of the burden from us. But still, no matter what is the percentage between tools that require us to write something or click on something, and tools that simply do things, there is a lot of manual work involved, definitely, throughout all this process. And the problem with manual work, and that's the problem that Ford realized early on, is the problem with manual work is that you cannot predict how much time you need to do something, because that work changes all the time. You don't know what you're going to have to do unless you have a crystal ball or something like that. So when we go back to assembly line, we see that assembly line, no matter whether we're talking about factory or where software should be or is today, is that assembly line is all about automation. It's how can we automate things in a way that they are repeatable and that they always produce the same results. Assembly line or a project, waterfall or what's not, is not about creative work. Creative work is unpredictable. I cannot predict how much time I'm gonna need to do something that I don't know how to do. And if I do know how to do something, then why do I not automate it, right? I assume that all of you listening to this are having a combination of doing some creative work and letting machines do stuff, right? We know how much machine needs time to do something, but I don't know how much time I will need to spend learning things or tackling the problems. Nobody does. So then happened, Agile came along after some old man met on some mountain, I think it was Aspen or something like that, came up with a brilliant idea how to revolutionize the process. And years later, we got DevOps because they forgot to invite operations teams, admins, and other people to the party. So it's in a way extension of Agile. But for all purposes, what I'm trying to explain, that there is not much different. They're trying all to be leaner than they were before. And then we got to that brilliant idea. Okay, well, let's have short iterations. Instead of us doing something for weeks or months or even years, let's have short iteration, maybe a couple of days, maybe 2 weeks, and see how it goes, and then repeat and repeat and repeat. And then analysts would send much smaller batch of things, much smaller number of features to developers. Developers would start developing, they would send it to testers, it would fail, they would need to repeat and start over again all the way until it gets to to operators, and then it would fail again, and it goes to operators again, and it finally works and goes to production. And those and weeks or days after we started with it, with that iteration, we have something in production that is working, and we can repeat the process over again. Now, that was a huge improvement for a simple reason, because scope is much smaller. You can concentrate on a few days of work instead of trying to figure out what's going to happen 3 years from now. At least from the planning perspective, is much better, and you can learn on your mistakes, and you can even allow yourselves to make mistakes because you know that they're affecting only days of work instead of weeks. And it finally goes to maintenance, goes to production. Now, the problem with that is that still, no matter how agile you become, and how many DevOps departments you have, still that is mostly manual, and there is that coupling between assembly line and creative work. And I want to make clear that that needs to separate. If you want to have assembly line, if you want to have a repetitive process, you need to make that process not involve you and move yourself into a sphere of creative work. Do something new every day, because that's how you're bringing value to your organization, your coworkers. So we got continuous delivery, continuous deployment, and it's very easy to describe it. Continuous delivery says everything you do, if it passes the assembly line, it's ready to be deployed to production. You can deliver out in automated way, and you just need to press a button. It will go to production without anybody asking any questions. Or even better, we can do continuous deployment and say everything that goes through our assembly line or a pipeline is going to be deployed to production. That's just the thing that I really like about that concept. At least when compared to continuous integration, is that there is no way to fake it. There is no way to say I am maybe doing it partly or something like that. Either every commit is ready for production or it's not, and that brings us much closer to that same assembly line. So we are gathering on the left side, doing creative work. And once we are finished with whatever we're doing, we're sending that something to go through that pipeline, through that assembly line, and repeat the same process. Maybe we will not get it right from the first attempt. Maybe it will fail some tests. Maybe it will fail to be deployed to production, or maybe tests in production will fail. And finally, after some time, not long, maybe hours, hopefully, maybe days, if you're unlucky, it will end up in production. It will be monitored there, and it will be maintained and up and running. Now, the problem with having everybody on the left working together as a single team towards accomplishing something that will be sent to that assembly line is that we need to be proactive. And proactive is much hard. Being proactive is much harder than it looks like. And that proactivity means that if what we are going to pass through that assembly line is a commit made by a developer, that means that everybody else, all of us, need to be so proactive that we are ready with our work long before that commit is made. So if I, as an operator or sysadmin, need to create some virtual machines, I need to do it in advance. If I'm an analyst, I need to prepare in advance. If I'm a tester, I need to write my test cases before the code is done, because that assembly line is initiated by a commit to Git, process-wise, not necessarily through tools. And then we can move and say, okay, then in advance, in a creative way, before we start building something, producing something, we're going to use all those tools that require creative work, like write code in IntelliJ or Eclipse if you're unfortunate. And once we're finished, and then we commit everything to Git, it goes on. And then we can talk about those tools that actually do the actual work in a mostly automated way to be incorporated into that assembly line. And then we can use VMware to create virtual machines, Docker to create containers. We can deploy it to Kubernetes. We can make sure that the process is aborted if it doesn't pass certain thresholds in SonarQube, and so on and so forth. And we have all those people during that process, like Santa's little helpers, making sure that all that is running. You need, okay, something is going on. We need a virtual machine. Let's go and create a virtual machine. Or, we need to build a Docker container. Let's build an image that will become a container, and so on and so forth. And those having people involved in all that process is what messes up with the concept completely. So they need to be removed, eliminated, and everybody truly moves to the left, where you actually do the work in advance, where you write your code. Everything needs to be code one way or another. Everything needs to end up in Git one way or another, and then the assembly is initiated. So let's try to see how we can do that continuous delivery or continuous deployment. Now, first thing that I said before, we need to eliminate completely humans from that story. We need to eliminate humans for everything that is done more than once, right? And definitely deploying to you're going to deploy the same set of pods to Kubernetes more than once. You're going to run Docker containers more than once. You're going to create virtual machines more than once and run your Selenium tests and so on and so forth. So you're doing it more than once. You're not a human. If you're a human, you're doing it wrong. You need to be on the left side and just write some code. Make sure that all the rest is happening. And that code does not involve only IntelliJ, I don't know, Java, JavaScript, whatever code you're writing, but code that actually will make sure that all those things above, like virtual machines and Kubernetes and Docker and what's not, that they are all ready, prepared, defined well in advance, and that those things can just happen when they need to happen. So we really need to replace humans. I want all of you involved in that assembly line. I want you to be, I was about to say firefighter is a wrong word. I want you all to move and do something creative, do something interesting, and let the machines take over. And that means that if you're going to remove humans, if you're going to remove Santa's little helpers, factory workers from the equation, we need some kind of executor that will make sure that all those tools are tied together. Because what is important is that unless you're in a startup or in a small company with 20, 30 people, maybe 100, you cannot solve things with a single tool. We know that in advance. All those attempts from before to create those monster tools that do everything, they failed miserably a long time ago. So we have a huge amount of tools that somehow need to be orchestrated, and yet all that orchestration needs to happen without humans. Now, of course, I'm working for CloudBees. I'm going to say that that tool is Jenkins, and you don't have to trust me because I work for CloudBees, but it's still, there is a fact that Jenkins has like 70% of the market share. So no, but you can choose any tool you want. That's not really an issue here, as long as you know that you know what you're doing, right? So we have Jenkins that actually will do all those things. That it's kind of, I actually think that instead of a Butler logo, we should have a drawing of orchestra conductor, because I think that that's closer to what it does. Simply, it will take all those disparate tools, tens, hundreds, maybe even thousands of tools might be involved in a process, and make sure that they are all executed in correct order, and that outputs from some of them are passed as inputs to others, and that certain dependencies are met, and so on and so forth. It's very complex operation if you're working in any but a small organization, and especially if you're working in an organization that exists for more than a couple of years, because things get accumulated, tools get accumulated, and the processes behind those tools as well. So a long time ago, as a solution to that problem, we got Jenkins. Actually, we got Hudson, that for practical reasons stopped being Hudson and then became Jenkins. And that was maybe like 10 years ago. Somebody might correct me, maybe 15. We got Jenkins, and Jenkins was really great because it allowed us to create jobs that do something, and we call them freestyle jobs. And then they do something like, there is a job that builds things. No, back in the days, maybe 10, 15 years ago, building things was enough. But soon afterwards, or almost immediately, we realized that simply building is not enough. We need to test, and testing is not enough because we need to run unit tests with one technology, and then we need to run performance tests with another, and functional tests, and this and that, and then we need to deploy to some integration environment and run another round of tests, and then we need to collect some metrics and then evaluate those metrics, and then we need to deploy to production. And simply, there is a vast amount of tasks that needs to be performed for an assembly line or a pipeline to be effective and to operate without humans. So we came to a brilliant idea: why not connect one freestyle job with another, and then you can have your assembly line that has I don't know, maybe 5, maybe 10, maybe 50 different freestyle jobs connected to each other, interdependent. Maybe some of them would run in parallel and so on and so forth. And it was great at the time because you did not need to know anything about almost anything. Because all you had to do is say, new job. And what do I need to do? I need to do something with Ansible. Excellent. Let me Google plugin. And then I install Ansible plugin. And then there are 10 fields that I'm going to fill in, like what is the address of your Ansible tower? It's this, right? And what is this and is that? And then you fill in the fields, and then you save it. And next time somebody commits something, a magic will happen. And that's great because you don't really need to know how to program, you don't need to know how to script, you don't need to know much about much. All you need to know is to find the right plugin, plug it in, create a job based on that plugin, freestyle job, and it does, and the magic happens. Now, as the time passed, it became evident that there are quite a few problems with that approach. First of all, when you create jobs in Jenkins, they are not in version control. And I'm very strict on that rule that if it's not in version control, it should not exist, right? We cannot have those hocus pocus type of things. The same way as we cannot, let's say, go to a server and do some magic on a command line, and then that server just starts working and nobody knows what you did. It's completely undocumented, it's not repeatable, and so on and so forth. So it needs to be in version control. That's one of the very important things, and that applies equally to Jenkins, to your code, to your tests, to your configuration files for Puppet or whatever you have, right? Second, running freestyle jobs, that works only for a simple logic. When you need, let's say, I'm going to build jar file and that's all I need, right? But as soon as you start doing complex things, and inevitably almost everything we do becomes complex sooner or later, because that's what we do. We make complex things happen. We try to simplify complex things, but we cannot remove complexity altogether from the equation. I mean, if it's very simple, then we would be out of jobs and our moms and dads would do it for us, or children. But it's complex, and what we do is complex. It's complicated, it's tough, and we need translate that complex logic into something that is much more viable for that. Then there is no unified view. There are a few plugins that would allow you to see more or less how those freestyle jobs interconnect with each other and what's not, but it really never worked. You can never really a place where you can easily visualize, okay, tell me what's going on. Where am I right now with this feature? What's the status of my project? What's the bottleneck? Where are we wasting our time, and so on and so forth. And finally, it cannot scale. Jenkins as it was, sorry, not as it was, it cannot scale, because as soon as you hit magic number of 100 teams or 1,000 builds and what's not, it starts struggling. So one of the things that we, the first one that is kind of quite obvious solution is how we tackle complexity, right? And Jenkins today tackles complexity in the same ways as any other development tool tackles complexity. You need to do something complex, you write code. Now don't get scared, it's a simple code, it's DSL, it's very easy to understand what it is, but it is still code nonetheless. Because when that complexity kicks in, you need a way to control things, you need a way to execute loops, you need a way to get results and pass them somewhere else. Maybe some switches or if-else statement. It doesn't have to be complicated to write it. After all, writing Jenkins pipelines is relatively simple, but it still produces solutions for complex things that cannot be done with freestyle jobs. For a simple reason, because it's code, and instead of clickety click. And being code, that means that you can finally, instead of doing it inside of Jenkins itself and thinking that it will simply somehow be maintainable, you can put it in version control, you can put it in Git, you can do pull requests, you can do code reviews, because if it's code, it must follow the same practices as any other code follows. And those practices practices dictate that things are, as I said, in version control, code reviewed, pull requests, what's or not, all the things that you do normally without that. However, once we start writing jobs in pipeline, we realize that, again, that does not scale, because if you're going to have hundreds or thousands of jobs and you're going to write thousands of pipelines, what you're going to end up doing is copying and pasting things over and over and over again, because even though every job is often different, it is still at the same time very similar. So simply writing pipelines as they are and copying and pasting was something that every developer would say, this is horrible. I don't allow copying and pasting things in my code across different services. We create libraries, and we've been doing that for 50 years. So there is no reason why the same logic wouldn't be applied to Jenkins pipelines. And then people came with the idea, but still it worked. I'm going to come back to tackling that problem of repeated code. But finally, if nothing else, we got something that is easier to maintain, easier to visualize. We could suddenly see where the bottlenecks are, what's the problem, what's the status. Jenkins could do the complex logic without having to write complex code or complex scripts, and everything was peachy. And then we got, and then if we need something beyond that, we could just go to a view and say, okay, just create me a job that will do whatever it needs to do across all the branches of my repository, or even better, across all the repositories within an organization in GitHub, right? And those all the repositories will be further split into different branches. And then suddenly magic started happening without us defining much in Jenkins itself, because all those pipelines are defined as Jenkins file and inside code repositories, and all we had to tell Jenkins, okay, this is my GitHub organization. Do the magic, get your Jenkins file, do whatever needs to be done, and finally we have a holistic view of what is going on with a single repository, and later on with the whole organization as well. And going back to copy and paste nightmare, finally got shared libraries that allow us to create equivalents of Java libraries or JavaScript libraries or what's or not libraries that have the common code upon which whole organization, all developers, all testers, and so on and so forth can discuss that common code and create things that benefit everybody, while still maintaining the possibility to go astray from using them by doing random and custom stuff in the Jenkins file. But there is still problem at scale. And that problem was because, as I said before, Jenkins, a single instance of not Jenkins, of anything, works well until we get to some scale. But if we want to apply those things across the organization and tens or hundreds or thousands of teams and a huge number of jobs and so on and so forth, we need to start thinking about how we can scale that up. And there were no real good solution until magic happened, and that magic, which I would say changed the industry or is changing right now, depending on which state you are, is called Docker, right? Docker allowed us that suddenly we can have any application immutable, defined as an immutable image and deployable on a server. And that means that suddenly we can have, instead of meddling with how we deploy 10 times this same thing, we can have just 10 containers or 100 containers or 1,000 containers running, producing same result, and allowing us to relatively easy scale whatever we have. However, that worked only on a single server, and as everybody knows, there are limitations. Server does not have unlimited amount of memory, CPU, and so on and so forth. So came Kubernetes, and before Kubernetes, Docker Swarm, and before Docker Swarm, Mesos. Actually, it's not before, they're all running in parallel. I'm using Kubernetes only here as one of the examples of orchestrators, but allowed us to take that concept of immutability, of immutable container images, deploy them at scale. And that suddenly opened doors that did not exist in the past. And that suddenly means that we can, with a relatively small effort, say, okay, one Jenkins is not enough. We're going to have 10, no, 100, 1,000. How many agents do we need? 10,000, fine. I'm going to scale it up. Whatever you need is just a container image away, and you don't need to think about where it's going to run, whether it's what's going to happen when it fails, how it will heal itself, because the platforms, container schedulers, or Kubernetes are doing that for us. And then we can open new doors with both open source and enterprises, where we can start thinking about all those teams and saying, okay, everybody gets its own Jenkins. Everybody, every team gets one or more, whatever the number is. We're not limited anymore with our infrastructure or inability to scale manually, because finally there is a tool that does that for us, and that tool is called Kubernetes, Docker Swarm, Mesos, or whatever whichever other container orchestrator you're using. And suddenly we got that button in Jenkins saying, okay, you want a new team, just join the company, excellent. Click this button, you will get a new master, and it will and you will be able to define your assembly line or pipelines, as many as you want, as long as it's yours, and it will just work. And then we go to really, really big scale. Actually, really big scale is not well presented on this image, but where we can create within a cluster, as long as we have enough capacity within a cluster itself, as many agents, as many masters as we need, and they will all live happily together, and they will scale up and down using metrics and quite a few different things, with, I cannot say zero, but almost negligible operational effort. At least negligible compared to if we would like to do the same thing before, because now we are finally, I think, as a product and as industry, moving towards, and not moving, we are moving for a long time, but getting to the point where everything is a service. So you don't need to ask anybody anymore for creating agents, for creating servers, for creating masters, and so on and so forth. It's just a service, and service means I click a button and I get whatever I need. So that was my very quick presentation. This is my Twitter handle. You're allowed to tweet. This is my blog. Read it. Courses, videos, books, and so on and so forth. I tend to finish early so that I have enough time for questions, and I think that's what we're going to do next. I cannot answer whether there is any. Johnny asked whether there is an issue with video, or is it him? I don't know. I cannot see myself. So somebody, Max, might be able to answer. So next one with from. Say again.
It was a little laggy here and there, but overall it's okay.
Okay, so from, I'm sorry if I'm not pronouncing names right. I'm terrible with that. Rajendra, maybe, something like that. Powerful tools in DevOps. I'm not sure how to understand that question, but yes, DevOps has, I wouldn't say that, I would like to clarify that. I'm not sure whether that was the question, but I don't think that there are truly DevOps tools. I just think that there are tools that are better than others. And if you adopt DevOps practices, meaning that your developers, developing and testing knowledge is all forming all inside of the same team, then you can better leverage some than the others. Like Jenkins can be a DevOps tool, containers, Docker can be a DevOps tool, but they're not, I mean, they can be used in DevOps organizations, but they're not necessarily DevOps tools per se only, kind of like, oh, if you're not DevOps, those are not tools. It's just that some practices, some tools, and some processes work better than others in DevOps. Murad, you heard it here. Viktor wants us to let the machines take over. Yes, that's what I want machines to do things that I don't want to do. And what I don't want to do is to wake up every morning and feel that I'm working in a factory. I don't want to do the same thing over and over again because that's boring, and more importantly, because machines do repetitive tasks better than us. I want to do creative stuff that is different every day, and that's where I think that I bring value to company I work for. Okay, David is asking about a copy of the video. Yes, that will be sent, or a link to a playback that will be sent. Then Michael, do you have any recommendations on storing environments, stack configuration values for deploying to AWS Google? Yes, recommendation is to store everything in Git. Doesn't matter what it's for, everything in Git. Trenton, what parts of SDLC should Docker containers be created? Example in POM files, etc., or later in the build process. So I think that just to clarify, first I assume that you're asking about images because you build images and then from those images you create as many containers as you need. So in which part? In all parts. A huge advantage, I think, and the huge benefit that we got with Docker is that it's one of the rare tools, and I think that actually Jenkins is in that group as well, that affect everybody in an organization. If you're a developer and you are developing something on your laptop, you want dependencies of your work to run so that you can try it out. You don't want to use servers for everything. So developers can run containers on their laptops and get full development environment easily. Testers want to create images with their tests and run it as a container later. Operators will want to build those images and deploy them to production, so on and so forth. So it's Jenkins is Docker is all around. It's in all phases. David Michael, will we be able to customize the jobs that create new teams via the CJ interface? Jobs that create. The idea is to make it intentionally simple because it should be simple and intuitive, and that cannot be done if there are 5,000 different configuration settings. So what I do believe is that when you create a team, you create a master, and for that master, you need to make sure that you know who has permission to access it and how much memory and CPU it will use. Those are the important things, and everything else that you need to customize in advance should be customized by creating an image. So create an image with a master that has whatever you need, and in that way you customize it, and then you just create as many of those as number of teams or whatever your organization is. Brian, can you elaborate more on how Kubernetes orchestrates stuff? So in the past, we were regarding deployments, we were very imperative. I'm gonna deploy this to a server called Mordor, and I'm gonna do this and I'm gonna do that. Kubernetes is declarative. We tell Kubernetes what is our intention, and now my intention is, let's say, to run this application with 3 replicas, and I expect this application to use 2 GB of RAM, and I expect that if it reaches 4, we have a memory leak and it should be shut down. Just a simple example, right? We tell Kubernetes what are our requirements, what are our expectations. We will tell him what to do. And Kubernetes, in turn, is going to do its best to comply with our desires. And that means that we stop thinking about servers as servers. They're becoming irrelevant for them. We start thinking about clusters, and cluster is a collection of all the CPU and memory of all the servers that form it. And then Kubernetes would just make sure that whatever we required, whatever our requirements are fulfilled, and not only at the time of deployment, but also that it's always fulfilled. So it will not only deploy the things to fulfill with our requests, but it will also make sure that it's always up and running, and that even that it's killed when needed. From Matt, can you run Jenkins Enterprise on premise, or is it only SaaS? You can run it on premise. You can run it on prem. You can run it on your servers, no matter whether those servers are on prem or in AWS or GC or Azure. You can run it anywhere. Now, depending on where you're running it, you will get more or less features. For example, if your infrastructure is not elastic, then it will not increase the number of servers when needed and those things. But short answer is it runs anywhere. So this is robotics from David E. Yeah, machine learning. I think that we're entering the age of machine learning, and artificial intelligence is around the corner. So beware. Yes, robots are taking over. I do think so. Matt from even store your secure keys in Git. No, secure all secrets, and I'm using very general term. Everything that is not supposed to be public should not be stored in Git. There are other solutions for that, depending on whether you want simple or complicated. So your secrets would be stored, let's say, as a Kubernetes secret, or maybe if you want to have it more secure, maybe you would use HashiVault. So yes, you caught me off guard. Everything should be in Git, unless it's a secret, like a password. I have a question, powerful tools in DevOps, but I really don't understand the question, so you will need to ask it again, Rajendra. From John, is Jenkins Enterprise supported on Microsoft Azure? So let's put it this way. Where we see future of Jenkins, so you can run Jenkins open source on Azure. You can run Jenkins cloud-based Jenkins platform on Azure simply because it runs anywhere. But where we see the present and the future is in Jenkins running in Kubernetes, and that means that as long as you have Kubernetes cluster, you should be able to run Jenkins Enterprise. We depend on Kubernetes, not on certain infrastructure below it. Now, that being said, there is a limited amount of combinations that we tested. So we know, I'm not sure about all the combinations that we're testing, but let's say that we verified that everything works smoothly in Kubernetes in AWS, and everything works smoothly in Kubernetes running on OpenShift, and so on and so forth. So there is a difference between what is tested, because there is a limit to number of permutations that can be tested. But the short answer is, if you run Kubernetes, it runs anywhere. From Dan, when the execution of a CI job pipeline fails, human intervention is required to find out the cause of the failure and get the fix committed. Isn't this kind of against the goal of automating everything? And I'd compare it with pushing the red button that stops the assembly line. Correct. So that's where fixing a bug that you don't know, that you didn't know about, and you don't know what is the cause of that bug, and you need to write some code to fix it, that falls into the creative section I was referring to. So assembly line fails, humans fix it. Now, that is not entirely true, because there are things that machines can fix. And I think that that's where we are going in. I tend to call that self-adaptation. So if something failed because there is not enough memory in a cluster, then machines can easily increase the amount of memory by creating more servers. That's easy to fix. But if you're referring to, since you're referring to CI pipeline, I assume that you're talking about the bugs in code itself. And that is to be fixed by human. That's not repeatable because every fix is different. So remember, assembly line is for repeatable processes. If it happened 2 times, it should be automated. Bug fixing is unique. From Michael, follow-up question. What about storing secrets? Some environments tax values cannot be seen by developers due to policies, regulations. I think I answered that. If you're using Kubernetes, for example, use Docker Kubernetes secrets. If you're using Docker Swarm, use Docker secrets. If you want to go further, I recommend HashiCorp Vault. There are dozens of other solutions and other tools that can help you with that. Juan, what are some of the more important technical skills that a newer practitioner of DevOps should focus on? Languages, tools. So, to clarify, and this is my personal opinion, there is no such thing as DevOps engineer or anything alike. DevOps is about joining expertise of development and operations and letting those experts speak with each other. Now, a developer might have sysadmin skills as well. Sysadministrator can have developer skills. That's not crucial here. What really matters is that a single team has all the knowledge to do everything. So what was happening with Agile implementations, not necessarily the idea, is that, oh, excellent, we have a team that knows how to develop and knows how to test and knows how to figure out requirements. And then that's our Agile team, and we do cool stuff, and then we send it to other teams to do the rest of the pipeline. DevOps tries to remedy that by saying, no. A team in charge of an application needs to know how to develop, needs to know how to test, needs to know how to build, needs to know how to deploy, and it needs to know how to make sure that it continues running in production. Now, whether everybody in that team knows everything, or people are specialized, and there is somebody with sysadmin knowledge or coding knowledge, and so on and so forth, that's a secondary issue. DevOps is about communication and forming teams that can handle everything. Not about being. There is no such thing as being a DevOps engineer. If you want to, I think that closer to being DevOps engineer, or a wrong perception of DevOps engineer, is if that's the direction you're taking, you should be called SRE, for example, Site Reliability Engineer, which are taking into account much bigger picture, and also educating teams than doing other stuff. Brian, can incremental builds be done in pipeline? I want to rerun only the failed stages. Yes, you can have checkpoints that will allow you to rerun parts of a pipeline only. Now, that's only until you make your processes be fast, and then when something, if it takes 15 minutes, as it should, I think that execution of a pipeline should be 1 coffee time. The time you need to go to the kitchen, get your coffee, drink it, and go back and do something else. But if your processes, if your pipeline takes, if it takes long for the pipeline to execute, then yes, you can define checkpoints which will allow you to continue from certain point in time. Present. Any architecture setup recommendation of running Jenkins in a Docker Swarm Kubernetes cluster? Now, that depends. If you use Jenkins Enterprise, then you get it out of the box. It simply does that. If you're using open source solution, then learn how Kubernetes works or Swarm, and make sure that you have network storage, and that you're handling memory and CPU well, and that you're handling your secrets. I cannot answer it here because it takes a lot of knowledge to understand how Kubernetes works. But once you do it, it should be straight. I cannot say straightforward, because till there, after you learn how a platform works, then you need to find out how to modify certain aspects of Jenkins to do it, or just go with CGE. So I'll gear the Jenkins specific. You preference pipeline or job DSL? Job DSL is dead, and I prefer things that are alive. That means pipeline. Jordan, can you rerun any of the stages? You can rerun from checkpoints. So you define a checkpoint step, and you can rerun from wherever that checkpoint is located. Justly, how to use images for DB updates? So that depends how your databases are organized. First of all, if they are done well, so that means that they're running as a database cluster. That means that they're replicating data across multiple instances, and that means that, let's say that if you have 3 Mongo databases and they're replicating data between themselves, you can shut down one of those 3 and replace it with a new instance based on newer image, and then it will get the data from one of the other 2 instances, and then you repeat the process. And that way you should avoid downtime, and that's called rolling updates. Now, if you don't have replication between databases, then you do need to shut it down and replace it with a new image, and then I would assume that you have 1 instance. And then you need to make sure that data is stored on a network drive. So as long as data is alive, you should be fine. Matt, sorry, meant to ask, is Jenkins Enterprise available to run on self-hosted? The answer is yes. Is there community open source edition? There is Jenkins community and open source edition. There is no open source edition of Jenkins Enterprise, but there is Jenkins open source. And then what is the prices for licensed version? I don't know how to answer that question. I'm a technical person. You need to contact one of the sales guys that will tell you anything about licenses.
Victor, real quick, we're approaching the top of the hour, so I just want to let everyone know that if we can't get to your question now, I put my email into the chat window so you can contact me directly. But why don't we do 1 or 2 more before we log off, because we have a lot of questions here.
Okay, let's do 2. Brian, non-image build artifacts are important to our organization. Will storing, queuing, build metadata data in perpetuity be supported? I'm sorry, Brian, I don't really understand the question. But if you drop me an email, I'll do my best to answer. Kyung, as far as Jenkins slaves, do you see benefit using Kubernetes as services or just use ephemeral Docker containers as commands? I believe that if you're using Kubernetes, the best way to operate Jenkins agents is most likely today through pod templates, which will create one-shot agents when needed and shut them down when not. And they're in a way similar to ephemeral Docker containers, but just work at much higher scale and are Kubernetes friendly. And there are quite a few other benefits. So Google pod templates for Jenkins. And the last one, David Michael, have you created any videos on Kubernetes and how it adds value to the isolated, immutable application instance? It is difficult to get this understanding message communicated to decision makers, how much value this adds. So videos about Kubernetes, I don't have today. I'm working on it, but I don't know when will they be available. Now, if you want to replace Kubernetes with videos with books, then I do have that. That's DevOps Toolkit 2.3. But for videos, you will need to wait for a while. Feel free to ping me, and I will let you. I will get back to you as soon as the first one is done. But the good news is that I'm working on that right now. And I think that that's the last question. Sorry, guys. Sorry for the rest of you who I couldn't answer. Time is limited. Max is going to freak out if I continue.
Yeah, thanks again, everyone, for all the questions. We do, like I said, we have plenty more we haven't gotten to. So if we weren't able to get to anything, just shoot me an email on the email address I posted in the chat, mrbuckle@cloudbeast.com. Otherwise, we're at the top of the hour, so I would like to close this out, make sure that we're respectful for all of you who have things coming up at this new hour. So I just want to say thank you to everyone who was here. Thanks for all the questions. Thanks for how many of you stuck around for the entire thing and listen to other questions and ask them yourself. And hopefully you all learned something. And thank you, of course, to Victor for the presentation today.
Hey, I love questions so much that maybe we should organize a session only questions.
Yeah, I think we could probably do that. We'll figure that out for anyone who has more. And if in the meantime, again, feel free to email me. So thanks, everyone. Talk to you soon.
Cheers. See you guys.